This video, we're going to complete chapter 0, and we'll begin chapter 1 next time. We want to discuss a little bit more about absolute value because we need to thoroughly understand it. Well, for all x in the set of real numbers, the absolute value of x is equal to radical of x squared. We can do that because even if x is a negative number, we're squaring it here, so we always have a positive number under that radical, positive or 0, if x is a 0. And also, x is always less than or equal to the absolute value of x. If x is a positive number, 0 or greater, I should say, then these are equal. And if x is a negative number, well, every negative number is less than or equal to a positive number. So that's obviously true. And now, let's take a look at these properties of the absolute value. We'll use all of these throughout the class. The absolute value of AB can be broken down into the product of the absolute values. It's equal to the absolute value of A times the absolute value of B. If epsilon is greater than 0, then this is true, the absolute value of A is less than epsilon, if and only if A falls in between epsilon and negative epsilon. That's what it means. That's what the absolute value means. It means that the distance between A and 0 is less than epsilon. The distance means that A is between, it could be either direction, but it's between negative epsilon and epsilon. The absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B. You probably have seen that before. That's called the Triangle Inequality. And here's another flavor of the triangle inequality. If you've got the absolute value of two terms and you're taking the difference, that's less than or equal to A minus B. It's a special, specific version of, or a derivation of the triangle inequality. And the proof is in the text. I'll let you look at the text for those proofs. Now, this theorem we just wrote, theorem 2.5, 0.25, implies, actually, this is probably specifically for part 2 of theorem 0.25. I'll just leave it at theorem 2.5. Implies that the following statements are equivalent. You'll frequently see this as the main part of a theorem in mathematical journals in an article. The theorem might say the following statements are equivalent, and it'll just list 2 or more statements. And the proof has to prove that they're all equivalent. All right, the first one. A minus B less than epsilon. Well, so far there's nothing to prove here because there's only one statement, so it's equivalent to itself. Let's look at statement number 2, though. That means that, just like we did in part 2, that means that A minus B is less than epsilon, but it's greater than negative epsilon. That came directly from part 2 of this theorem. Number 3. Another way of saying this, and another equivalent way of saying that, is that B, if A and B, the distance between them, which is when you take the absolute value of a difference, that gives you the distance between A and B. Well, if that's less than epsilon, then I can say that B is less than A plus epsilon and greater than A minus epsilon. It's within epsilon of A. And similarly, I'm going to put A in the middle. And it's between B plus epsilon and B minus epsilon. So these 4 are equivalent. And frequently we'll have to prove this, and to start off, it's easier to write it like this, or maybe vice versa. All right, to finish up, let's do I'll write over here a couple more sentences. Recall that what I just mentioned, you may have seen it written like this before. The absolute value of the difference between A and B is equal to the distance from between A and B. It's an undirected distance, so this is equal to that. So all of these are equal. So I should put an equals there and an equals there. And then one more. If I take the interval a minus epsilon, a plus epsilon, that's frequently called an epsilon neighborhood around A. The interval, all of the numbers between a minus epsilon up to a plus epsilon, this is equal to the set of all x such that x is between those. So make sure you're very comfortable with everything in the board right now. We will be seeing this throughout the semester, especially when we're doing proofs.